So we're looking for 2 volunteers, please. If it makes anyone feel stronger, we have a volunteer already for our backup note taker. So we have one of the 3 people in place, but we do need a note taker and a Jabber scribe to start doing all the fun we're going to have.
Bob, did you send the slides? No, okay, well, Gory may have to do that because I think my web filter admins don't like your website, and I can't debug it in the next 10 seconds.
Okay, and Goring has Thunderbird running under Catalina. And if you're on the Thunderbird support team, I love Thunderbird, and I know it's not really a supported product, but please can we make it work properly in Catalina? I want the drop-down menus to work. Right, where's Bob? Briscoe. That's easy. That's 21st.
Yeah, it is.
Yep, that's all right.
Laptop thinks it's back in Boston, so that's why.
Okay, it's still the 21st here. That's what matters. Bob, you sent 2 emails on the email list. Can you? You're just going to send. Aha. That'd be good. Shall we put up the agenda while we're going?
So what we really want to do here, oh, wait a minute, it's that one. You're going to have to do it over there. That's the laptop. Or you can hand it to me or something.
Shall we swap places or something? That'd be more sensible.
As well. Yeah. I had not realized who was supposed to drive
we
what.
We are a multi-operating system set of chairs here, but we can't simultaneously multi-operating system. Right, I'll get blue sheets.
Okay, I started working on that first blue sheet. Let's go for. Fortunately, power cables are long enough. Amelia, yes. Welcome to the adventure.
Are you all right?
I'm not. No, but we're going to cope anyhow.
The orientation of us being up here and you being down here.
Okay, now.
I jumped up to go to the mic. We're going to fall off the stage.
We did learn something interesting here, which is materials work better dispatched from that page. Cool. Alrighty. Alrighty. Okay, so. Okay, this should work. Famous last words. Our dispatch off of this page, it's easy. We will have a little bit less in. Wait a minute, so I hit click. Yeah.
Oh, you're getting stuff.
Okay.
We're still looking for a offer for a note taker.
That works. One just never cease.
You're doing well. Okay, we can start. Let's start. We are going to be short of time in this session because we're going to introduce an extra presentation which we had to skip from the previous session because there was a lot of discussion there. So timekeeping is going to be important, and we'll remind people of that. It may be in your interest to make sure that your talks allow time for discussion rather than get cut off before they finish. So please make sure that you keep to time. Note well, this is covered by the IETF Note well. The small print does matter if you haven't read it, including the anti-harassment and many other useful things that are written in here. Please have a look at it. Oh, we're going to have to stop again because we do need a note taker. If we have no note taker, then we won't be able to proceed with any of the discussion we intend to do in the meeting, and that would be pretty sad. So please, can we have a volunteer for a note taker?
Thank you, Stuart.
Thank you, Stuart. Is somebody able to sit in Jabber and just check whether there's anything coming up from Jabber? Thank you, Mira. We can proceed. Our agenda for today consists of UDP options. This is a working group item. Stuart?
Just want to make a request, since I'm taking notes. When you come to the microphone to speak, please say your first name, your last name, and if applicable, the company you're representing, because if you don't, I will be trying to work out who you are, and then I won't listen to what you're saying, and then it won't be in the notes.
Okay, and for coordination, Teresa is the backup note taker, so you might want to coordinate with each other. Okay, so thank you ever so much for volunteering to do things. The DCCP multipath presentation will be taken here. Again, we need to keep to agenda time, so keep moving. L4S will be discussed. The 3 working group drafts will be presented. There will be the issues discussion following that. There's an allocated set of time for that. We will use that time. Please focus on the issues. SCE will be discussed. These 2 individual drafts will be presented afterwards, and we'll take discussion there.
So I think these agenda slides have been overtaken by events, to borrow a phrase from elsewhere. I believe that the 2 drafts we're going to talk about here are the Morton SCE draft and the Cheap Nasty Queuing draft. The Grimes TCPM draft is tomorrow morning's adventure in TCPM, but it's been included here on the agenda because if you want to understand how SCE works, you really probably got to read that draft for completeness.
David is correct. The QCI draft will get time, and we'll talk briefly about QCI and DiffServ, mainly to bubble up the discussion there because there are other things that will have to go on before we take that one forward. You want to talk?
Okay, and we're going to try, let's see, there's normally the last half hour of the session is these 3 drafts. Now, we know we're going to get very, very excited with the agenda items that come just before this, but at some point we are going to call time to try to get these folks at least a little bit of time, even though they're not going to get their 15 minutes of fame.
And the last 2 drafts are the spin bit and the DiffServ in-band signaling. Does anybody else want to try and bash the agenda apart from the chairs? Is there anything that we've missed? Excellent. Then we shall begin. I'm proxying for Joe. Excellent.
Orange shirt's the wrong color, of course.
Hi, I'm Gory. I'm proxying for Joe Touch on the UDP options draft. I'm not in this wonderful location on the slide. I'm in Singapore. UDP options is a working group draft. It's progressing. So Luke, at the draft, please. One of the changes was there was a proposed change of status to BEPS rather than experimental. As ever, the chairs have looked at this, but the final decision on the status will come from feedback from this group and our advice from our AD. But there has been that change, so be aware. There were some additions. These 4 additions came directly from the working group meeting last time, so your contributions via email and at the mic have made a difference. Joe's updated it to reflect the OCS, the ACS. Post options must be 0 to eliminate the idea of a side channel, and extended the format allowing more than 255 byte options, which allows for padding type uses. Next slide, please, David. There's discussion about PAD-N versus PAD. In other words, the PAD-N option, like similar to what we have in IPv6, and whether we need that. Joe told me in the discussion before this was presented that nobody really had commented on the list after this was discussed in the working group meeting last time. So if you're one of the people who thought this was interesting, even important, then please get back on the list and comment on it. Because if Joe doesn't get feedback, it's Joe's opinion that nobody really cares that much. So if you do care, please just speak up. There's a flag for must support discussion as well. People thought that that was really, really interesting. And we could divide the option space numbering perhaps to reflect those with one number, one set. Maybe the higher numbers were required and the other ones were not. But did we really need that? Again, there wasn't much discussion on the list after the discussion on the mic. So if we don't get feedback and discussion, there's no way we can draw consensus to add new things to the document. The call for use cases for these is unanswered, in other words, and as such, there was no new text added by Joe. Next one. Path forward. Light and frag integration was going to be added. In other words, Joe's responding to the request that we got rid of the light as a separate feature of UDP options, and we simply allowed it as a way of performing fragmentation. So remove the generic light mechanism on the basis that UDP light is only used in very special deployments, and we don't need to support that in the UDP options space. That also could have some simplification to the document, so that might come in response to several comments that people have made. And that means also that frag will then depend upon something that's UDP light-like. Next one, please. Is that the end? Okay. That's the end. As you can see, Joe has a little bit of work in the pipeline, but if you want more work, then please comment on the list. And any questions? Some questions. Oh no. Any questions on the UDP options work? Yeah, come on. Please use the list. Joe's not actually attending the IETF, which is why I'm standing up proxying for him, so he really needs input from the list if there is going to be working group contributions.
Let's try to do 10 minutes if we can.
Go ahead.
Good morning, Max Arment from Deutsche Telekom, and today I want to talk about multipath TCP. I had already the chance at ICCRG to present some results. Some of these results are also part now of this presentation, so I will skip them because of time. And but I want to focus today a little bit on the draft updates we did since last time. Starting with a short introduction, with a short recap, why we are focusing on multipath TCP. We think there are multi-connectivity architectures already specified or under specification like 3GPP, ATSSS, and also BBF hybrid access, which defines multi-connectivity between CPEs or mobile phones and carrier networks. And we see there's a strong demand on multipath protocols supporting UDP or even IP. There's already the multipath TCP out, which can support TCP, but we see an increasing share of UDP in our networks because of the QUIC, and we think it would be good to have multipath support for this as well in the specific architectures like ATSSS and hybrid access. We selected the DCCP protocol for that purpose because of its unreliable nature, but it keeps a state and employs congestion control, what we think is very useful. So you find some materials which point this out in detail why DCCP is, from our view, the right protocol in slides from IETF 104 and 105, I think. That is the framework we have in mind. So it's mainly relying on a multipath support for DCCP extended by a multipath framework, which more or less means we have virtual network interfaces where we can send IP or UDP traffic in, it's encapsulated, it's transferred over the multipath DCCP, and then exit the virtual network interface on the receiver side again. So pretty simple. There are 3 drafts related to this. And the work which has been done since IETF 105 is mainly related to the multipath DCCP draft. The other 2 drafts are more or less unmodified. So in the next slide, I will explain a little bit what has been done in the multipath DCCP protocol we propose. Also, we worked on implementation and generating results, but that I will more or less skip today because it was part already of the ICCRG presentation. One important thing, we also implemented in the meantime that you can see in the middle of the slide, DBR for DCCP, and maybe within the next year we can also make this open source. Let's see. Okay, now coming to the extensions we did to the multipath DCCP draft. It's now version 3. We added a multipath capable feature to the DCCP, and also a multipath option to exchange multipath specific information. We defined several multipath options for setting up a multipath DCCP connection securely, adding or removing subflows securely, enable receiver-side reordering, which is one of the main critical points for an efficient implementation, we think. And also giving path priority. So you can see on the right side which options we have defined so far. And also we defined a handshake procedure. I will not go through it in detail. It's pretty similar to multipath TCP. We think that in multipath TCP there was defined a mature handshaking mechanism for multipath, so we more or less adopted this. Okay, so that is the part where I usually plan to present some updates on our implementation and results. I will go through it quickly. In the past or in the previous time, we already proved that there's a possibility for seamless handover, keeping IP connectivity when we switch from one access to the others, that you find in the slides from IETF 105. We also proved that it makes sense to have a reordering on receiver side. Again, the details you find in the slides from IETF 105. And what is new now, and I already explained at ICCRG, that we made a setup for testing real traffic. In that case, we tested with YouTube using quick transmission over or through our multipath DCCP setup. We tested it under various path conditions. And the results, or some of the results you can find here on this slide. We proved, for example, that multipath, or our multipath DCCP solution always provide a better performance over single path. We can also deal with changing path characteristics. So in this example, we combined two paths with 1 megabit, and we changed on one of the path the latencies after 60 seconds. And in the results, you can see the blue dots, that is single path, so 1 megabit only. And all the other results, red, green, and gray, that are different modes of our multipath DCCP setup, using different scheduler, using reordering. So we have the SRTT, that is pure scheduling, preferring the path with the lowest latency. And then we had 2 scenarios with fixed round robin a fixed ratio scheduler, sorry. It was in an 80-20 setup, and one that is the active with reordering and the passive without reordering. And we see a clear benefit of having multipass DCCP with active reordering on receiver side over all the other scenarios we tested. In future, we plan to extend this test with our brand new BBR implementation because all the tests we did so far were relying on the CCID2, and we think with BBR we have some benefits over CCID2. But I think that we will see next time. Conclusions and next steps. So our prototype implementation and simulations we did so far shows very good first results according to the demands of steering, switching, and splitting of 3GPP, ATSSS, and hybrid access defined at the Broadband Forum. The key components we identified for efficient multipath is scheduling, congestion control, and reordering. We see a possible interference between the congestion control employed in the multipass DCCP setup and congestion control of piggyback traffic that we addressed this time at ICCRG. So I will start some discussions on that on the mailing list soon. We have now a BBR implementation inside the Linux kernel for DCCP available, and we expect very good results using BBR instead of CCID2 related to multipass purposes. Several discussions with operators and vendors have been initiated now in the context of 3GPP standardization, where we make very clear that we believe that it requires multipass support for the increasing UDP share. That does not mean that it ends up in a multipass DCCP setup. It could also be something else, but at least to make the IETF community aware that there is something needed. For that reason, I think the multipass DCCP is a very good thing, and at least the algorithms for scheduling and reordering could also be used in any other protocol. In case you want to support us, you want to contribute, you find all the related multipass DCCP drafts at GitHub. Thank you.
Okay, questions?
Roland Bless, KIT. Did you implement BBR version 1?
Yes.
Okay, then you should also consider sending multiple MP DCCP flows at the same time, because then the BBR model more or less breaks, and this will at least double your RTT and so on. So either do it with version 2 or at least consider that bad things may happen in case you have small buffers. Maybe not in your case, but
thank you for this comment. So that was a first step for us to overcome the limitations of CCID2, and think even with the BBR version 1, we can do it better than with CCID2. However, we also consider BBR v2 in a following step, and also maybe couple congestion control.
Yeah, my point is that I expect very good results if you have only one MP DCCP flow with BBR. That works nicely, because then the model fits. But
got it. Yeah.
As soon as you have multiple flows,
you have to. Yes, I share your opinion, but you have to see here we have a very dedicated focus on multi-connectivity between customer devices and carrier network. Maybe that then this is not an issue, but we have to consider this. Thank you.
Andrew McGregor, Fastly. I wouldn't quite characterize the way BBR goes wrong as in exactly that way, but the point remains it does, and strange things happen with small numbers of flows in certain networks. So yeah, it'll be a bit weird. Okay. And BBR2 is better. I think this is valuable work. There are plenty of places where something like this could be useful. So, yeah.
Okay.
Yeah, thank you.
Okay, we'd like to get more discussion of this going on the list, but we'll move on to the next presentation.
I'm going to inject one last closing comment as I'm sitting up here. I want to strongly encourage the work on what is referred to as congestion control of piggyback traffic. This phenomenon where we see stacked or nested congestion control loops is turning up in multiple areas of the IETF, and some progress on figuring out what's safe and what isn't would be very helpful.
Bob. Just start, Bob.
Right.
Tell us about your 3 L4S drafts that are working group items.
Okay. Right. There's the names of the 3 drafts. To be honest, this talk is more about status of what's been going on and implementation and things like that than the drafts, but there is a fair bit about the drafts next.
Oh, I'll do this. There you go.
Okay, so a recap of what L4S is.
You don't just done this?
But that was a different meeting. So it's ultra-low queuing delay for all internet applications, and including capacity-seeking ones. So that means you can have high throughput and very low delay. And the trick is to use congestion control with small sawteeth. What ultra-low queuing delay means is around a millisecond, but also it's very important to get the higher percentiles low, so it's got to be consistent for real-time applications, because otherwise, if some packets are late, they buffer to the longest, not the shortest. And without looking at all the detail in here, this was a large number of short flows and long flows, and still getting very low queuing delay. But I won't go into the exact details because we've got a lot more to do today. And the final introductory recap slide is that those scalable congestion controls that allow you to get that low delay, they also appear to be very aggressive to a TCP-friendly flow if they're in an ECN queue together. But if they're in a non-ECN queue, that's fine because you get a loss and you can deal with it. But we've got a transition mechanism so that this new traffic can be isolated in another queue, either a dual queue system as drawn there, or a per flowing queue, which I didn't draw because I hadn't got that much pencil. The other transition mechanism is a packet identifier to be able to isolate these flows in this dual queue system, because you can't do it with the flow IDs when you're trying to just do it for 2, or we don't want to do it for flow IDs because you might want to do it in encrypted VPNs and things. And finally, the picture shows there the transitions for the UC encode point we're proposing to use for this solution. Right, and I've now got 4 slides on implementation status. Low latency DOCSIS first. There was a working group formed on this in October 17. Greg's done this useful slide for me. I no longer consult for Cable Labs. 89 individuals representing those companies there. I won't read them all out. You can see them on the screen. So that's, I don't know, something like 20 companies, is it, Greg? I mean, including the 12, yeah. More than 20, yeah. Integrated the L4S dual queue into the DOCSIS 3.1 MAC, and also developed 2 concepts. In fact, if you go to these slides online, there are links for things like the non-queue building traffic and the queue protection algorithm. And all the features are managed to be implemented by a firmware update so no hardware updates to cable modems, so it can all be installed on existing modems. And the news this time round, there's been the specs were published in January. We told you that, and there've been.
Bob, while you've been interrupted,
That's to let my chickens out.
that's to let your chickens out. Excellent. Good luck doing that over IPv6. When you say that this work has gone on DOCSIS, did they do it based on the spec that we have here at the IETF? And do they have any feedback on whether that was implementable? In other words, has it helped you or
that
not?
feedback has been put on the list, and that's why the people who were doing it, Dave Pullen, someone else, they put their list of changes they needed in it, and some of it was fed through me directly, and I posted it on the list. Yeah.
So in other words, it has influenced the RFC to be if there is one. Yeah,
and in the DOCSIS spec, it is the dual Q IETF spec is a normative requirement for that. Right. Yeah. And so the news right now is that in September, that was the first interop event, and two cable modem vendors had already produced the implementation. Just to be clear, there are only 2 cable modem silicon vendors or implementers. And at that time, there was one CMTS implementer, and then we just had another interop with 2 of each, 2 cable modem and 2 CMTS. And in DOCSIS, for the low latency DOCSIS, the upstream service relies partly on the CMTS, so you need both to have it employed for it to work. Whereas in the downstream, just the CMTS is all that's needed. And 3 more events planned. Any more to say on that, Greg? No? Good. So the next update is that the Nokia have implemented a Wi-Fi product with L4S in the stack, and that is due for product in Q1 2020. They've got other devices planned later around that idea. It uses the dual Pi 2 technology, which is in one of the appendices of the dual Q document, and that was demonstrated at Broadband World Forum just a few weeks ago. And Nokia want you to know that if you want to have some trials on this, and I hope it's okay to advertise this, contact their business unit, Nokia Home Digital Home Business Unit, and there's a URL. And the third development, actually, I was hoping I might get an email on this because I think the meeting has just finished. So I don't know what the outcome is, but the 3GPP are meeting in Reno in Nevada at the moment, or they've just finished, and there was a proposal to include L4S support in the 5G system architecture in the SA2 working group, and the proposal was from Ericsson, Sprint, Google, Nokia, and AT&T and Vodafone for enhancements for advanced interactive services, AIS, and that included, again, a requirement for both low latency and high throughput for those sort of applications. So that there's been a number of attempts to get ECN supported in the system architecture, and we're hoping that this one will succeed. There's no guarantee it will. There's a hell of a lot of things trying to get into 3GPP, but we shall see. Excuse me.
2 minutes.
Right. And these are all the open source. The one that's additional this time is the NS3 implementation has now been open sourced. We've been promising that for quite a time, and it's finally happened. And a test suite around it. Most of the other ones, well, there's BBR v2 is coming along the alpha release. And I think all the other ones have been there already, but they're obviously being updated all the time. And I showed this on Monday, so I'll skip very quickly through it. This is status against the Prague requirements as it was in July, and this is as it is now. And you'll see it's nearly all green apart from the RTT dependence one. The one I showed on Monday actually included BBR, but we've done it just for one implementation, the reference implementation here. So one of them is still orange, or yellow, I suppose that's called. So we're nearly there, but there's still a lot more work to do. But I think this shows that the requirements are meetable, if that's a word. I've got one slide on SCE versus L4S. I know there's been plenty of discussion of this, but I've got the mic.
For 1 minute.
Yeah. So that's the two code point schemes along the top to show the difference. And I just wanted to sort of put the main issues there, that the primary issue with L4S is that scalable flows would dominate classic flows in a classic ECN AQM if you didn't have FQ or some form of per flow queuing, with the condition that such things are deployed somewhere, and if the fallback scheme that we've developed doesn't work. And I'm going to talk about that in the issues time. Whereas the primary issue with SCE, I think, is similar in that per microflow classification is really needed. And if you don't have it, I don't think it's been shown that classic won't dominate SCE. And so I characterize these two issues as one is that L4S sort of dominates the past, or that somewhere there may be something it dominates, whereas SCE, I think it by design gets dominated for all time in the future. And that's why I would have chosen L4S if I'd have seen these two together when we had all the other issues that we were considering about tunneling and lower layers and all the rest of it to determine which code point to use or which scheme to use.
You're probably done.
That was that it? Oh yeah, the drafts. There was 3 updates. Okay.
Okay. Questions on the drafts of presentation, but not on issues. Then I'm going to get. Okay. I have no idea what we're doing next, David. Can you come to the mic and tell me which buttons to press to bring whatever we need to do to happen?
So do I go and sit down?
Depends on where we are. Now I've just got a bunch of PCs to look at. I'm doing other things here.
Yeah.
So my agenda says, yes, you sit down, and we have Wes in charge, which means I have David helping me get Wes in charge. So Wes, hopefully, Wes is there. I press the red button and Wes appears.
Can I relay something from Jabba quickly, because I was a little late here? Okay, so Ingemar is on Jabba, and he said, reporting back from the 3GPP. The SA2 contribution was just discussed in Reno. The reception was overall positive, and some additional proponents with some pushback. It's currently unclear which timeframe LS4 support will be added in standards. We will have to wait for debriefing after next week after the meeting with more details.
That was very useful. Thank you for bringing that so quickly to us. Bob, I think you probably can sit down or stand at the mic and help. Yeah? Oh, sorry.
Yeah, and this is David. I've gone to sit down in the audience because apparently I'm Her Majesty's loyal opposition on this one, and I'm hoping we get to the point where loyal is more important than opposition in that term.
I didn't really need the mic. I just wanted to say to you, we've prepared slides about each issue.
Oh, right. Okay. Well, I don't know.
Background information.
Fine. Okay. I have no idea. I think I hand over to Wes and see if we can actually have a remote chair. Wes, are you there?
Yeah, can you hear me?
Excellent. We can hear you.
Great.
Okay.
Should I start talking?
Okay. Can you see the slides, Wes?
Yes, I can. Yeah. So, sorry I can't be there, but I am the document shepherd for the 3 L4S drafts that Bob was discussing. And according to the charter, we're going to be trying to finish these in June of this year. So we're a few months behind, and we knew that this was going to happen. But we would like to eventually get to a working group last call. And so we wanted to take some time in the meeting to talk about criteria for sort of what it takes to publish experimental RFCs on congestion control in the IETF, and what we're doing to work all the issues to closure in the documents so that we can get to a working group last call and hopefully do it successfully and wrap these up. So starting off, it's important. We're not doing L4S for proposed standard or standards track. We're specifically targeting informational and experimental RFCs. Plenty of RFCs exist similar to this already, so this is not like we're blazing a new trail or anything. There are RFCs we can look at for sort of level setting guidance on what the expectations should be. RFC 5033 was brought up on the mailing list recently. It was a really good thing. It sort of lays out things that congestion control specs should be assessed against. And in fact, the DC TCP RFC has a good example of going point by point through the items in 5033 and sort of stating why or what's been done in terms of DC TCP with regard to them. And I wanted to mention Quick Start as another example we have of experimental RFC on congestion control. It's particularly applicable because it involves both in-network components. So in Quick Start, the routers are signaling some information about how fast a flow can go. And it also has end-host behaviors too. And so L4S is a little bit of an odd thing because it's the drafts that we're working on in TSVWG right now are primarily the in-network behaviors, and then there are some requirements, the TCP prog requirements that flows that are using the L4S ID are supposed to meet, but we're not actually working on the drafts that describe a protocol doing all this stuff at the moment. So separating TCP prog from L4S a little bit is different between this work and Quick Start. In essence, though, the goal of doing experimental RFCs on congestion control is always to not break the internet. So, we work the RFCs, and there are some open issues and questions usually in these things, and that's why we're going for experimental rather than proposed standard. But it's important that we have consensus, and there are things that are in place in the RFCs that make us feel like we're not going to break the internet. So if the experiment goes badly, there's mechanisms that are available to operators and sysadmins to see this going badly and put the brakes on it. We need to maybe do a little bit more work on that in the current drafts, I think. But this is the point of doing the work out in the open in the IETF, the way we're doing it. There have been many things not done in the IETF that went badly. So like the old BitTorrent, old Real Player are a couple of examples people might remember. That's not going to happen here because we're doing things in the IETF, and we're going to make sure that this is avoided. So I go to the next chart.
Question from Jake.
Yeah, hi, Jake Holland. Do we have any kind of normative or prior consensus on what the word break here means? Because I think you'll probably find easy consensus that this will not cause congestion collapse if that's the definition of break. But I'm not sure you'll find consensus that, like, for example, some of the tests that are brought up, right? The existing deployment of like gaming routers that promise to provide low latency already and do so through the use of AQM. Some of these, there's pretty strong reason to believe in some cases that that some of the observed L4S behaviors may introduce like persistent and frequent queuing delay to these systems that were specifically designed to try to avoid such things, right? So this is the kind of, like, does that count as breaking or not?
So that's where the, like, did you have the ability to observe what was going on that with the L4S experiment, and that was the cause of the breakage, and then easily turn it off? Then you could say, yeah, there was a temporary problem, and
Right.
it didn't break the internet because someone could manage the problem.
Yeah. I have no objection to like trying that once and then, checking with the gaming routing owners if that's the plan. But I guess I'd like to see kind of what break means here before,
There's no RFC about breaking the internet. So
Great, thank you.
Mira, Mike.
Yeah, Mirja Kulewind. So my understanding was that in this group we rather specify requirements for congestion control, and then the actual congestion control work would potentially go to the group that also cares about the protocol. So, okay, you're nodding, that's great. But that also means like breaking the internet is not like the big issue here, because like the requirements itself would not break the internet, I hope.
I agree.
Next slide then.
Yeah.
Wait.
Oh, previous one. Yeah, this one. So we're trying to make progress towards working group last fall. So towards that end, at the last IETF meeting, we discussed a number of individual issues we were trying to tease out from the email threads. And I put all these into the IETF track tool. And the URL here, you can click through on your computers and go visit. But one thing to keep in mind is we want to keep the main discussion on the mailing list, not go back and forth in the track tool with comments. So the intention is to use the tool to record like the main status, and then when there are a bunch of web pages and papers and things that we want to refer to or point to towards closure or progress on the issues, we'll do that in the tracker. But don't go back and forth there. Use the mailing list. And then don't jump to it yet, but on the next page I have sort of a stoplight chart that I wanted to get out to the working group, which is my interpretation of the status that each of the issues is at the moment, and whether or not we look like we're about a document revision away from being ready for a work group last fall in each of them. And so I would like to, after this meeting, start closing issues in track. If there are some that we're obtaining enough of a agreement on that sufficient work has been done or sufficient document have been made that we don't think this issue would block publication anymore. It's not indicating that every problem is solved and that this is the perfect protocol for all pieces on the internet. It's indicating that it looks like we've met the criteria for experimental RFCs, basically. And it's just because I click through and close an issue and track it doesn't mean that we can never discuss it again. It's still perfectly valid to bring up in a working group class call at any time on the mailing list or in any other venue. It's just that I may close something because it looks like we're trending towards being good. And then I also wanted to say, as co-chair and document shepherd, this is a little bit confusing at the moment because we're talking about the L4S experiment and its use of the ECT1 code point. And we may have another set of specs using ECT1 code point. And we discussed with area directors, we're not planning on like holding up L4S publication while that other spec is worked on. We will, if it comes to it, we'll have to figure out how to make them coexist, but we're not going to block L4S because of it.
Question from Jake or not?
Yeah, sorry, Jake Holland again. Just a quick clarification about the back and forth on the issues list. So I thought part of the point of the issues list was that things were getting dropped in these sort of voluminous email threads, and that the goal was to capture the main
yes.
points to be tracked with the issue itself. So I just, although I am totally in agreement that we do not want circular arguments on these threads and to make them also equally useless, I just want to make sure that it is correct that the main key points should be captured in the issues.
And it's been very helpful. People have been adding things. I actually intended to add some things myself, and then I'd visit an issue, and I saw, some people have already added stuff
Great.
to them. It's been very helpful what people have done there. I just wanted to make sure that if everyone in the room starts clicking through, that we don't all feel the need to add our 2 cents to the.
That's it. Thank you. Just wanted to clarify.
Yeah, I think the intention is that the chairs, or particularly Wes, tries to make sure the correct things don't go missing, so we put them in the tracker. So
right.
It isn't like a discussion GitHub, but this is a step towards that, so we just don't lose stuff.
Yeah, and the idea is that, like, as we go towards a working group last call, if you wanted to look up how it looks like an issue was dealt with, there would be a lot of links and information there to help with that.
So you have the issues list.
This is my stoplight chart on the issues, and it's, again, my own thoughts about whether we're about green means we're about a document revision away, from what I could tell. Yellow means sort of like I really don't know if we're making progress, and red was sort of it didn't look to me like we had made progress. So I don't know if it's readable in the room. It's barely legible through MeetEcho, but I wanted to get this out there to the working group because it at least summarizes what I'm seeing. And I didn't really want to talk about it a whole lot in detail because I wanted to give Bob time to talk about issues 16, 17, 18, and 19 in the room. But you're certainly free to talk about it with me or with the working group. One thing I think is worth noting is that a lot of the issues seem like they're pointing to number 16 now, like the classic Ekin interaction. That seems to be sort of a crucial issue that several others hinge upon. So I think when Bob's talking about that today, we want to see if that's going in a good direction.
Okay, so now's the point when we're going to discuss issues. Just before we do it, has everybody signed the blue sheets? If you haven't signed the blue sheet, can you put your hand in the air? Okay, can we find the blue sheets? Thank you. Let's carry on. So we're going to discuss issue 16, Wes? If anybody wants.
Yeah, or give it to Bob to discuss.
Well, I need David back if we're doing slide changes.
I think Bob had work on this.
Yeah, right. Start going. We'll get slides when we get David. With 3 chairs doing 3 jobs.
Back to the slides.
Then Bob's presentation slides in the slide deck that we just presented. Yeah, but you should say something anyway because you've only got a small number of minutes.
Yeah, the first slide you're going to see will be a slide that or a picture that was in the report, and I think we've shown it before, which is the maximum or the characterizing the difference in rates between a cubic flow and a DC-TCP flow in different. Yeah, that one. Yep. In this case, a pi squared AQM. So both of them with ECN capable. If one of them wasn't ECN capable, there wouldn't be a problem at all because there would be loss, and then it would DC-TCP responds to loss as if it's Reno. So this shows something like between 4 and 16 times fairness, and it's difficult to know whether that's acceptable or not, and it sort of depends whether this is happening like all over the internet or in 1 or 2 corners of the internet maybe. Yes, it's still a pain for that person it's happening to, but it's also only happening when 2 long-running flows are going together, and they're also 2 different flows. So, you know, it's not good, but it's not starvation. They're both stable. They both proceed, and also the other interesting fact about this is that as the capacity for each flow gets smaller, or as there's more flows, the capacity per flow gets smaller. They get more equal. So, yeah, it's not good, but it's I don't know whether we leave it to the floor to decide whether it's acceptable.
Comments?
Anyway, yep.
Is there any comments? Come to the mic.
Andrew McGregor, Fastly. That's not great, but it's not catastrophic either. Yeah, it's given the fraction of flows out there that are actually that long running, it's almost like, hey, Classic has just turned into our less than best effort transport. Oh well.
Jay Collin, the ones on the left there, is that not indicating starvation for some portion of the flows? It goes all the way to the bottom of the log scale.
The line is the mean. The little tick is the mean, and that's the first and 99th percentile.
Right, so the bottom end of the 99th percentile goes down below 1% of the of the normalized flow rate for the competing flow. Is that correct?
And that's samples taken every second, not whole flow lengths. It's sometimes
I
the rate
see.
was
Okay,
that low.
so the mean represents the entire flow?
No, the mean represents the mean of all the seconds.
Of all the samples. Okay, so we don't really know whether it's only where space is left that. Okay, this might bear further examination. The other one I wanted to mention was that I thought the guidelines from 2914 suggested that fairness, a goal for different ideas, was within an order of magnitude. Some of these data points cross the line, but most of them don't. Yeah.
Anyone else? No.
Please come to the mic if you do have opinions, because we'd just like to use some of this time just to at least talk about it, if it is an issue still.
Marco Koyo. So this is when DCTCP and Cubic is competing. Okay, so do you have the results where same number of cubic flows are just alone without DCTCP? So that is what you should compare to the results in these slides for cubic to see whether there is harm for cubic.
I didn't understand how many flows. How many cubic flows did you say? Just 2?
Whatever number. Let's say you have 8 cubic flows, and then you replace 4 of them to be DCTP. And now with this setup, you compare the cubic results to the cubic only case, to see whether there is any harm.
One assumes that under equal conditions, because all these ones are equal round trip times, they're only comparing the same round trip times.
Exactly the same setup, sharing the same link.
They're the same link.
Base RTT, same link.
Yeah. So, and it's the same AQM, same queue. So if there were 2, and these are just one against one. So if there were 2 cubics, they're going to be pretty much on the one line. The number 1, by the way, is when it says normalized rate per flow, that's what you should get if they were equal. So it's taking the capacity if there's 2 flows, dividing it by 2.
Right, but do we have the results for this to compare?
To compare just cubic versus cubic?
Yes, against the results for cubic here on this slide. That is to see whether there's harm or not.
Yeah, okay. I mean, the mean would be 1. I don't know how big the variance would be, but no, I haven't got in this slide set. I haven't got those results. I mean, they're easy to do, but
that would be useful to have.
But they're sort of going to be 1, aren't they? I mean, would anyone expect?
Can I ask a different question, Bob?
Yeah.
Do you think they're really easy to do? Could you do them and just post the one slide to the list?
Yeah.
Okay. Then we can then the conversation can happen.
Yeah.
Jay Collin again. I was going to ask for the same for Reno. This is just for cubic, right? We're sort of expecting Reno to be perhaps less aggressive and perhaps to even have a larger swing. I'm not sure if I should say, but we do sometimes use Reno from our data centers, and it's not just cubic everywhere.
Yeah, I mean, we have done experiments with Reno. We can certainly post ones with Reno. Yeah, and
okay. So you'll post maybe an update slide after this.
Yeah.
Okay. Jana
Iyengar, just a clarification on this whole line of inquiry. We know this is going to be the case. We know that DCTCP is going to sort of do this with regular ECN. What are we trying to accomplish by doing all of this work?
Are you asking me?
Well, I guess I'm asking folks who are asking for more evaluations, and also from the chair, because it is an issue now. Is this something that the question here in the room is not so much? You put these 2 flows in a single queue, DCTCP is going to kill the other one. Fine. How slowly does it die, or how badly is it hurt? Is that an interesting question for us to be asking?
I do want to just point out, as I've said before, that starvation usually means something ratchets down and down and down and gets nothing. They're actually reaching a stable state, these 2, and there is progress in both of them. So it's not killing it. I know. As I said, it's 4 at the ends and about 16 in the middle. But we're talking here like the 40 meg in the middle. So
okay.
I don't know, 1/16 of 40 is not an insignificant amount of bandwidth.
So rather than discuss whether we've got that, is there another piece of data that we really want to look at? If there's easy things to do, we can add it to the slide and we can finish this discussion. If there's something very specific that people are asking for, please ask.
But Andrew's question is relevant.
Yeah,
what are we going to
Andrew's
do with this information? You know, do we have a target?
You told me it was easy, and if this is the only issue that people are raising, then I take this as we add this and see if people say, "Oh, that was easy, that's done."
I mean, this is important.
We're heading there.
Because this is really the only intractable issue, with L4S that SCE was invented to solve. You know, and if it's not an important problem, then, but how do we know? What's the consensus on whether this is important or not? You know, where's the line? Where's our target? What are we trying to do? You know?
I'm sure Wes will say something when we've got this conversation through. Does anyone have any more things that they want to kind of say needs to be done in this evaluation?
No, but I do have something I want. Andrew McGregor, fastly. I do have something I want to point out, was that if we do this exercise for cubic versus cubic or Reno versus Reno, we're going to get numbers that are somewhat less than 1 because they will fail to fill the link. Yeah. So we'll get numbers somewhere between about 0.5 and about 0.7. So that's really the bar, right? That's really the bar for it's actually working okay. Here we're filling the link, so we get more total, close to filling the link. You can never fill it completely. So, yeah.
Okay, so we need to close the mic soon, but please comment on this specific thing.
All right, so Peter Heist from the SCE team. I wanted to answer the question why we're doing this experiment, and that is because there are many RFC 3168 AQMs in deployment today, so we want to demonstrate what is actually going on so that we show and not just talk about what could possibly happen, because it is a serious issue. But I did want to ask, I didn't know if it came up in this issue or 17, but you have resolved some of the initial latency spikes that were due to the alpha in TCP prog, the initial alpha value.
Yeah, that's issue 17. We've got that coming. But if we take this along on everything, we're
okay. So
yeah. I mean, there's another 3 or 4 slides about this. Okay. This is just the problem slide. Now we've got the solution coming up. But I do want to pick up on you saying there are a lot of 3168 routers about. We're talking here about single. These are all in a single queue. If it's an F queue, you don't get this problem at all.
Jay Collin, just to speak to the point Jana asked about why do we want to know this, I would like to say that I am far more interested in how well does the classic queue detection work. If you would do that instead and show that this goes away when it's functional, then it would make this moot. I think what this serves as is a baseline in case it doesn't, and to be able to show the difference. And we don't actually need it if we don't, if the classic queue detection works for, both against Reno and against Cubic. Yeah.
And I've got bad news for you. As I said in the previous meeting, Assad's been ill this week, so we haven't actually got results on that. We've implemented it, but we haven't been able to test it in the time we've had here.
Right. But I'm going to give Jana a chance to say something short, and then I'm going to try and get Wes to say what he wants to do with the remaining time.
Wes looks very eager. That little blue thing is really moving. Jana Iyengar, I'm going to say that it's always interesting for me to hear about ECN deployment, because everybody thinks it seems to me that it's super difficult to actually find out what ECN deployment looks like. So if actually somebody has numbers or has experience, I would love to see that. I am curious. We've seen this in the past, but I'd like to know that.
That's on the next slide.
That'd be useful, yeah. But
okay. Right, okay, but I'm still going to let Wes speak. Wes, have you got the mic?
Yeah. Can you hear me?
Okay, so Wes, chair to chair, we're eating into the individual presentations, so we'll be cutting those if we continue for a lot longer. But there might be useful things that could be done. How would you like to use the next 10 minutes?
I think a key is to see if people agree that most of the work here is actually in TCP prog on end hosts, and that as L4S is concerned, we need just sort of the existence proof that it's possible to do the classic ECN bottleneck detection and fallback and whatever, and that this is enough to make us feel comfortable going forward with the L4S in-network behavior RFCs.
So that's a question to the room. Will
But
people-
Bob didn't even get to show his charts on the detection and fallback yet. So.
I know, but is it still a question to the room? How comfortable are people with that position?
Jake Holland, if we had such a proof, that would be adequate for me. I would. That is the open question to me. It's like, can we in fact meet the TCP prog the L4S requirements with anything? One example of which could be TCP prog. We haven't seen that yet. That's my objection.
And the particular L4S requirement that you thought was important to gate on was fallback in some way with 3168 compatibility. Is that right? Yeah, nodded yes.
Okay. This slide is holding off one more slide until we get to the design of that fallback, just to talk about, because this issue is both about the prevalence of the problem and whether there's a solution. And where we asked Padma, who presented this stuff in a MapRG some years ago now, to dig into the data, and she did remember that she had looked into the highest point there, the 30% in Argentina, and traced it to a particular ISP. So we found someone in that ISP, or Greg did, and they had a look and they said, it looks like we're overwriting the TOS byte with hex 17. And so they seem to be doing that on all of them. So that could well explain that 30%.
Mm-hmm. Well, I like that data, but I'm not sure it's the right place to dig at this moment, isn't it?
And that's why we started doing the work on TCP prog, because I thought, no matter how much we find that there isn't any single queue ECM, we're always going to get the complaint there might be. We can't prove the existence of the non-existence of something.
It's in many of the routers I have as a configuration option. So, right. So where's
is it on?
No, but it's there.
Yeah.
Wes, what do you want to do next?
Well,
I think we probably should move to issue 17, Bob.
Well, I mean, there's how the design works for issue 16, and then issue 17 I was going to skip over because it's sort of pretty much done. Yeah.
Skip?
No, I was going to skip 17 and not 16.
Okay. Well, you're not going to skip 16.
Yeah. No.
But this is about what?
This is about how we have designed the solution.
But you haven't. Have you got data showing
No,
this?
we haven't. No.
Okay, then it's in the slide deck, Bob.
I can skip it all. Yeah.
Yeah.
Okay. Right. So then, right. Very briefly, issue 17. Do you want to go to that? Just why I reckon we can skip it.
I'm going to try clicking.
Yep,
right,
that works. Right.
And 16.
Usually just point and grunt.
Oh yeah. 17.
Yep. So that was a copy of the problem statement from Pete, I think. I'm not going to read all that out, but it was essentially saying that, excuse me, that there's this case where quite often a cake router is set up so that in the downstream, the home router at the end of the downstream end of the link is made to be the bottleneck slightly less than the capacity than the FIFO at the top of the link, and they were concerned that there were measurements showing that TCP prog was giving this huge period of congestion that was big enough to push back up into the FIFO. So next.
Well, okay. I mean, so do they still hold that belief?
I do not believe they do, because if you just show the next one.
Yes.
What's happened there?
Yeah, well, I realised this was coming.
This bottom of the oh no.
No. Just tell us.
Right. That was the problem observed, but it was a bug when Olivier had copied over from TCP into TCP prog and then started turning it into TCP prog. He'd one of the initial parameters for where the EWMA starts was meant to be at 1 or max, and it was set to 0. By the way, he copied over the parameters, so that was what that initial bit was. And if you look at the next slide,
I don't think it matters. I think they're all okay.
did that?
We could have perhaps. Yeah, it's fine.
Okay, thanks. Yeah, so, and in fact, in Pete's original measurements, DC-TCP didn't have the problem and TCP Prague did. And it was because we'd introduced a bug in TCP Prague, which once we realized those two differences, immediately found it. And then if you look at the next plot, it's,
Yeah, that's where I need to scroll.
you can just see, yeah, that's it. A little bit further down. Anyway,
Yeah.
you see the the delay is on the right-hand side. If you can read that, it's about that spike is about 150, but the rest of it is about, I don't know, 5 maybe on the TCP flow, and hardly anything on the ICMP. And the ICMP is will be going back into FIFO, and then the next. So essentially, the problem's gone away. And if you look at it, the next plot, it shows essentially other congestion controls have the same size spike.
Right.
So this one seems really clear, Bob. I'm wondering if, to save time, we should just go straight to the one on the loss detection time units, where you have ways forward, because I think that would be helpful to get feedback on.
Okay, so we want to take comments from people. I mean, Bob's spoken, but comments from the floor on these two issues. And yeah.
Right. With respect to the initialization of alpha, I believe that is basically, this is Jonathan Morton, just to okay, initializing alpha to 1 essentially means that we have a multiplicative decrease on exit of slow start. Isn't that right?
Mm-hmm.
So what happens when you have a sudden decrease in effective path capacity after alpha has stabilized to the steady state value?
Right. What happens is that as with a lot of these things, we're experimenting with a TCP Prague that isn't finished, and we've got the pace chirping stuff that we have used it with.
Pace chirping is still about slow start, isn't it? I'm talking about after slow start has gone away.
It's not. No. We've got pace chirping and excuse me. Pace chirping is also when the congestion level disappears mid congestion avoidance, and also we're working on a faster controller instead of the EWMA. Well, it's in addition to the EWMA, it's a PI controller within data center TCP, which, well, not just working on it, it's implemented, and the guy who wrote pace chirping is implementing that because he wants, in order to come in fast, the other flows have to go out faster, and DC-TCP is very slow at doing that.
Okay, so there's some work in progress that we haven't seen yet.
Yes.
And it's again in Prague.
That's actually,
code itself.
I presented this work in the ICCRG and at NetDev, but it's not been shown in TSVWG. Right.
Jake Holland, there was another different latency spike that happened with the staggered start. Greg made a statement on list about this is a different thing. I was less clear, or I didn't see that analyzed. It looked to me like a similar issue, but I agree that it can be fixed by fixing 16 probably, or I'd like to see it demonstrated.
So, Greg White, Cable. I think the issue you're referring to is the same one that Jonathan Morton is bringing up, that if TCP Prague is in a steady state with a small value of alpha and in an FQ system, and another flow starts up, that the FQ coddle doesn't give enough of a congestion signal to meet the expectations of TCP prog and cause it to reduce its congestion window as quickly as it could.
Right, but it still does make a multi-second latency spike in much the same way as I recall. And this is so I'm surprised to see this represented as the conclusion to the issue.
But that latency spike was only affecting the TCP prog flow. It was not causing collateral damage to other flows.
I thought it was the same issue in the Sebastian thing where you have an upstream flow and that one can back up and cut. Okay, maybe I'm mistaken. Thank you.
And note the conclusion thing is Bob's take to reach a conclusion, not the chair's determination that has happened. The other question, I've got a small question here. You mentioned the use of paced chirping. Mm-hmm. Is it possible to find a method that doesn't use paced chirping? For those people who have offloads and other things where that might be hard?
What Ilpo is doing at the moment is, he's currently upstreaming accurate ECN, but the next job is to look at whether pace chirping is practical or whether we go for something less ambitious as a sort of first step that gives you a better startup and faster, but not as necessarily as good as pace chirping, or maybe we use pace chirping when it works and something else otherwise. But I mean, it will always fall to slow start if that's better than pace chirping anyway. So
I would encourage you to look outside of the pace chirping thing for something that the IETF can standardize, and then explore pace chirping where you can deploy it. But I don't think there are any RFCs on paced chirping, and so you should be careful to have a way of doing it that works within the RFC series, and then improve on that with a separate RFC.
But also if we can get pace chirping as an RFC, that would be even better.
Right, but I want to get. I agree with Wes. I'd love to see these documents published. So I don't want to gate on some future RFC to come on anything. So anyway, can I go back to Wes and you have the last say?
I have a question on what the goal is here, because we're all doing congestion control research in ICCRG.
Yes.
And are we meant to have solved all congestion control problems before we can get the L4S drafts?
I would say, whether chirping is the answer, we wouldn't necessarily change anything in the 3 L4S documents, that we're working on right now. So if those don't depend on the specific answer, then let's just not spend time today talking about what specific answers are, and just.
So if I paraphrase Wes, give a simple answer to these questions, because the development of the stuff can be done somewhere else.
And I guess the simple answer is we're doing this faster getting out of the way part of the work, which isn't pace chirping, but it's because we want pace chirping to push in. So if we did the faster getting out of the way bit, that would probably solve all these problems.
Time check. I think you've got 40 minutes left in the session, and in addition to SCE, which is normally 20, I think there's another 3 presentations behind it. How much more time do we want to spend on this, and to do what?
It would be really good to get quick feedback on Bob's proposed way forward on the loss detection and time units. He's got, I think if you skip 2 charts ahead, 3 charts ahead. One more.
Yeah, that one.
This one.
Would that satisfy
you? A couple minutes on this and be done, I think.
So
because people are familiar with the problem and the controversy.
Okay. So Bob, do you want to talk about this, or do you want me to go?
We've decided we're going to go for should, if that helps get us moving.
David Black, as an individual speaking on the floor, I strongly endorse the should here, and I will cheerlead to the extent I can that people really, really, really should do this. We can get must down to a should. We'll take care of this. We'll take care of this for me, and I think we can go forward with that. Okay. We'll have to check on a list, but a should would just take this one right off the table. We can focus on the hard problems.
Richard.
So Richard Schaffenegger, NetApp. So one question. So many stacks have reordering detection, which dynamically adjusts the reordering interval in packets over time. Would that be an alternative method to do this, or must it be time units?
It can be. I mean, for instance, just to answer that question in a way that shows you the extremes that you can go to. If you did 3D pack, but you paced your initial window, for instance, if you did 3D pack for your initial window and then moved that towards time, using time later in the flow, the 3D pack would be in time because it's 3/10 of the round trip time if you pace over the round trip time. Do you see what I mean?
Yeah, and this is David. One of the things I'll reinforce. Bob mentioned, I think, in the session, previous one, that we had a lot of discussions. One of the things I think became clear from those discussions is that pacing helps. Pacing helps a lot here.
Yeah.
Yes, but some stacks do not have pacing. So that's...
Yeah, I mean, pacing in general is something that can or cannot be present for various reasons in an endpoint.
And my question is for stacks that do not feature pacing, chirping, blah, blah, is it acceptable to have them declare themselves compliant with the TCP PROG specs if they do something like reordering detection?
Well, if we put it as a should, yes.
Mm-hmm. Good.
That's the goal.
I'm Joanna from Huawei. I think it's the optional solution for the network path, for example, tunnel or SP. In this scenario, I think it's the necessary solution. I have submitted one draft named ICANN. I think have the same scenario. Yeah. Please pay attention to my draft. Thank you.
Okay. Thank you.
Thank you. Thank you. And Jana? I'm going to say something as well. Jana?
Jana Igor. So this is the one requirement that sort of sticks out on the list as a slightly wonky one, and I think we've gone over this. But I think the goal here is to, if I understand it correctly, is to basically make sure that the endpoint is resilient to the network doing things that it is constrained from doing right now, because TCP has a 3-2 back thing. Again, as we know, the implementations are changing this, but Praveen mentioned something earlier to me that I realize is probably worth just bringing up briefly. Loss detection in time units at the endpoints is usually implemented as a fraction of the round trip time. In the network, however, the switch doesn't necessarily know your flow's round trip time, which means that whatever resilience we are telling them we are building is not really visible to them. The degree of freedom that we believe this might provide them might not translate into the degree of freedom we want.
We've had this discussion on the list. It's
okay.
Even though the network doesn't know the round trip time, it generally knows a rough minimum round trip time that any node has got. Because by the diameter of the network, the minimum diameter of the network, that it's been installed in.
It has to track that, but yes, it can track it. That's what you're saying?
Yeah.
So I guess where we are going here is what I wanted to suggest was definitely a should. If you're going to have this, I think it should be a should. I'm increasingly feeling strongly about that. Separately, I wonder if this should be amended to actually talk about endpoints being resilient to reordering in the network beyond the 3-packet limit. What's your name, Richard? Thank you.
Yeah.
Richard. Yeah. What Richard said, sorry, it's Thursday morning. What Richard said is appropriate, that if there are endpoints that are doing packet-based or doing adaptive packet-based thresholding, then that's also good enough. Basically, what you want is the endpoint to not fall over if there's more reordering in the network. And I wonder if there's a better way of saying that rather than saying loss detection in time units.
Thank you, Jana.
Let's try and
Praveen?
Work out some words on this.
I think that's a useful contribution. Jana?
Praveen, I would be supportive of a should here. I think it's less clear if the goal is actually to have the endpoint do loss detection in time or just be more reordering resilient. So I think calling that out would be useful. Second thing I would like to say, the current transport specs are not enforcing the dynamic reorder requirement. So it might be static, right? So unless we change the transport specs in TCP and Quick to say that the reordering should be dynamic, either in packets or in time.
So I want to place myself in the line. So, but no, wait, I don't know where I want to place myself. Maybe I'll place myself on the chair still. So here I am. As a chair, I find it difficult for us to relax the reordering constraint in the internet layer, unless we write a specific draft that does that. And I tried to make comments earlier to make sure that the text here talks about being resilient to a network that might do this, and not motivating that particular change in this document. If we get the transports to all be resilient to reordering and more resilient, then that document could appear here and we could discuss it. But we shouldn't put the cart before the horse, because otherwise we create a document that really will have to get IETF consensus in a difficult way. So if we're heading in that way, I think I would have finished my comments. So I will read the new text.
You already have read it. And
I know. I know.
I thought you've reviewed it for me and
said this.
It.
Yeah, exactly. But you.
So is it right or not now?
Okay. So I need to check again, because at this IETF, people talking about L4S have again mentioned that the long-term intention is one thing which I didn't understand it to be. So I need to make sure the text is correct.
Because I mean, I did work out a way of saying it without implying at all that the network was going to change. It was more that if the network stays as it is, and the hosts will keep to this. You know, I worked out a way to do it that I thought satisfied you. And
well, I think a bunch of us need to bash the text offline. I will probably have some concerns about the specific text, but let's bash it offline.
Yeah. But we seem to have a reasonable way forward on this, I think. Okay. Wes, would you like to comment on this? And have you got anything else?
Other prisoners their time.
Excellent.
Good.
We should spend some time on our remaining documents. We have 1, 2, 3, 4, 5 individual presentations in 30 minutes. And we will seek to do what we can. But if the authors help us, that would help a lot. I think we'll take Jerome's QCI thing very briefly as a point of information so we know where we're up to. So, well, okay, but I was hoping to give the rest of, okay, fine. Okay, we'll put SC and SCA if you want. Yeah, that's fine.
While you come up, can I
just... Are we doing SCA? Yes. Okay, we'll take SCA. Your time limited to 10, including questions, so 5 for presentations.
I just wanted to point out to Wes, in the previous session, we tried to address the measurement issue, which I can't remember which number. It's 21, no, not 21, 22, something like that.
Wes will pick up.
Because I don't think Wes was there.
Oh boy, squeezing this into 10 minutes is going to be tough.
Which one do you want to focus on? Or you just want to go through your talk, yeah? It's fine.
Yeah, I think we'll go through the talk. I wanted to spend a bit more time on these early slides, since I think a lot of the information was also presented at Montreal, but seemed to get lost when it filtered through to the mailing list. So, let's start with the NAT's eye view. Some congestion experienced. RFC 3168 left a spare code point in the ESEN field at the low end of the TOS byte, and one of its suggested uses back in 2001 was an indication of mild congestion, with a CE code point showing severe congestion. That's exactly what SCE is. We're just filled in a few details about how to make it work in practice. One such detail is in how to get the ACE feedback to the server, to the sender where it's acted upon. We propose using a single reserved bit in the TCP header, as shown here. Originally assigning that bit, obviously assigning that bit as a TCM TCP/M working group matter, and Rod will talk there about it tomorrow. The crucial aspect of SCE is that we've taken pains to preserve all the existing functionality of RFC 3168 ECN within SCE. This means that ECN and SCE endpoints and middle boxes are completely interoperable with each other by design. This makes incremental deployment considerably easier. What this achieves is an end to the perennial trade-off between link utilization and queuing delay. The basic cause of that trade-off is the traditional congestion control sawtooth. If the peaks of the sawtooth are kept at low delay, the troughs will be somewhat below link capacity. SCE replaces the sawtooth with a continuous cruise control feedback loop. Next slide, please. Here we have some famous quotes which everyone in this working group should be familiar with. I'd like to draw attention to simplify, then add lightness, quoted by the founder of a very successful racing team. Next slide, please. This is all about getting information from the network about the network to the endpoints trying to transport data across the network. There have been many attempts at this over the years, and the only protocol that has stood the test of time and implementation is ECN. Published in 2001, almost 20 years ago, and just seeing significant practical deployment in the past few years. Those of you working with IPv6 will know that tune. Before ECN, the only robust indication of congestion was when packets got lost, usually when a dumb FIFO overflowed. ECN allows an AQM to tell the receiver of its traffic to slow down without dropping packets, an act which wastes upstream capacity and causes application delays due to head-of-line blocking. The net effect is that observing ECN signals is a good indication of a better quality of network service, reduced loss, and lower latency. RFC 3168 defines the CE code point to carry this information from the AQM to the receiver, and the ECE TCP flag to carry that information back to the sender. ECE is a sticky bit released by CWR response from the sender, making it a reliable signal. However, it is an imprecise signal. Of course, old endpoints and datagram transports can't understand the CE signal, so the sender informs the network that it understands the AQM signals by using some code point other than not ECT, usually ECT0. SCE adds an additional channel of information from the network to the receiver, where a drop or a CE mark requests a large reduction in send rate, SCE requests a small reduction. The receiver reflects SCE precisely, but without an explicit reliability guarantee, using the ESCE bit. Okay, next slide, please. A crucial feature of this approach is that there is no ambiguity at the receiver or the sender in whether the network is requesting a large reduction or a small one. Existing AQMs, especially the most widely deployed CE marking AQM, which is CODEL, expect CE to be interpreted as requesting a large reduction. SCE preserves this meaning by providing another code point to carry the request for a small reduction. Therefore, SCE transports run correctly over all existing networks, and existing transports run correctly over an SCE network, including networks formed of arbitrary mixture of SCE, ECN, and dumb FIFO nodes. Next slide, please. SCE marking can be added to existing AQM algorithms, and many techniques for SCE marking are feasible. In general, we expect SCE marks to be applied at lower queue depths and at higher rates than CE marks, such that flows which respond to SCE may be able to avoid receiving CE marks. The diagram on the right should be familiar, and not only because I showed it previously at Montreal. It's a red wrap, which we initially used to add SCE support to CODEL-based AQMs. More recently, we've started using CODEL for SCE marking as well, which tends to improve SCE's performance on bursty paths in the same way as CODEL works well on bursty paths.
Question from Stuart.
Stuart Cheshire from Apple. Just a clarification about that graph. Where you say sojourn time, do you mean the instantaneous sojourn time for a particular packet or the minimum over the last 100 millisecond window?
It's instantaneous.
Okay. I think it would be good to clarify that because everything else CODEL does is the minimum over the window. So if you mean instantaneous, I think you need to call that out as an exception.
Okay. Well, for the red vamp, we're using the instantaneous time. For CODEL marking, we're using the normal CODEL algorithm, but with different parameters.
So this is Richard Schaffenegger. Just a quick clarification question. In the range where you say CE marking, I presume that this will also have 100% SE marking continuously. Is that correct?
That's correct.
Okay. My question is, where's drop?
Drop is not shown on the graph. You would do dropping if the queue overflows, obviously. In our Cobalt AQM, we also have a blue algorithm which can do random dropping in case of unresponsive floods.
So if drop is just a defined limit, do you guarantee low latency, or is low? How do you mix the delay properties if there's no limit on the drop?
Well, obviously, if you have a not ECT transport, then that will get dropped whenever a CE mark would happen. SCE does not influence the drops.
Right, okay. Thank you. That clarifies it. Back to Stuart, though.
Richard asked a question, but I think the answer was wrong. In that area above the target where it says CE marking, you can't have 100% SCE because you can't have both. You can either mark a packet SCE or you can mark it CE, but you've got to pick one or the other. So if it's CE marking, that means it's not SCE. You can't have both.
Right. So as a clarification, we say that every packet is marked SCE if it is not otherwise marked CE, and that may include incoming CE marks.
Mayor Kuhleman, can you iterate a little bit what you mean on backward compatibility? Because, like, my understanding is that if you have a non-CE aware and a non-SCE aware and SCE aware flow competing in the same SCE queue, that you would see a very different behavior than, without SCE, right? So, like, I'm not sure if that's like fully backward compatible or like, what do you actually mean?
Okay, I do actually have some prepared answer for that. So we're talking about SCE fairness, two non-SCE flows in a single queue, and vice versa. The easiest solution is to leave single queue nodes without SCE marking capability. This takes advantage of SCE's backwards compatibility in terms of drop and RFC 3168 marks. The CE response is not materially affected by SCE, and this provides a robust solution. Alternatively, the upgrade of a node to support SCE marking should be taken as a golden opportunity to install some FQ capability. At the most basic level, this could be CNQ, which I'll describe later, but of course a true FQ algorithm would prefer fairness better. Some networks may choose to employ diffserv to isolate an SCE-enhanced application.
I have is there a follow-up question? Okay, so I have a question to you. You have 3 minutes remaining to give the other presenters at least a few minutes each. And I would also like to use the sense of the room to see how many people have read this and have some thoughts on it. So is there any way you would like to end your talk would you like to choose which slides you have?
I think if we move on, so next slide.
Just keep going, yeah.
And I think we'll leave this one for TCPM.
Okay.
And okay. We have done a brief evaluation of SCE against the Prague requirements. And I think we meet one, and at least arguably, we meet two through the ESCE flag. Next slide. We definitely meet three. We meet four by design. Next slide. Number 5 is the one where we don't meet. Because we're actually worse than Cubic in single queue competition. But that's something we can work on. Next slide. Scaling active fractional congestion window. We can use pacing scaling to demonstrate that. And in fact, we had already done that at Montreal. And as far as reordering tolerance on time basis, well, we're using Linux, and Linux supports that. Okay, next slide, please. And there's a brief summary of our progress since Montreal, which I think I'll skip over today, except to say that we've begun an evaluation of SCE according to RFC 5033, which will continue. Next slide, please.
Can we cut there? Can we cut there? Yes. We should have some time for questions.
I've got a question about the first
if we
bullet.
Can go through to the penultimate slide, I think.
Which is where this
next steps.
That one, yeah.
Okay, so we are requesting working group adoption of the SCE draft. We believe SCE is a useful experiment that is already safe to deploy in the general internet. We're happy to back that up assertion with data. Some comments have been received and noted. We will continue our RFC 5033 evaluation. There are some bugs in our implementations to track down. We want to research methods, blah, blah, blah. We have a lot of flexibility here.
Okay. Let's take questions. Bob?
Yeah. First of all, I just wanted to reinterpret what you said about SCE in a single queue. Essentially, you said SCE is starved in a single queue against Cubic, and so the fact that it doesn't work isn't a golden opportunity for the operator to do FQ. That's a précis of what you just said, just for the room that may not have followed the very long sentence. And if they don't want to do FQ, it's not a golden opportunity.
Well, they can, of course, just leave it as it is, and it'll continue working just as well as it always
If
did.
something doesn't work, you can just leave it as it is, and then you can't have the supposed advantage, but that's not the solution.
I mean, the point is you don't need to replace the network in order to deploy SCE endpoints.
No, but you don't get if you believe there's an advantage of deploying SCE, you can't have the advantage if you don't deploy it. You can't say that the solution is to do nothing.
You still get the advantage if the bottleneck happens to be elsewhere, but at the same time, it's still safe if the bottleneck moves to the single queue.
Okay.
We're going to cut the queue, or else we can't do much more. And we need to actually keep the questions within like 30 seconds.
Okay. The second part of my question was that CNQ is nothing to do with SCE because you've still got all the long-running flows all together in one queue. So it doesn't. It only takes the sparse flows out.
It limits the degree of unfairness by preventing starvation.
We should have that draft presented when it's stable.
Yes.
Jana Iyengar. I'll ask this very quickly. My understanding is that the goal of this is ultimately to get low latency transport. And if that's the case, I want to put that as the first requirement, and backward compatibility as a secondary requirement, perhaps. That's my personal opinion. My question in terms of understanding this is something that came out of the discussion you were just having. In a backward compatible environment, in the world that we are in right now, what benefits does SCE get me? And if I need to get a low latency transport, do I need to change the network?
Right. Yes, you do need to get the information from the network to the endpoints in order to gain SCE's advantages. That's the whole point. It is a signaling mechanism.
The signaling mechanism doesn't give me low latency. It gives me a signal.
Yeah, it gives you a signal that the sender can then respond to.
But if it's a single queue?
If it's a single queue, then you are unable to deploy SCE with FQ there, then you just have to leave it as a single queue with RFC 3168 capability, and that is already a big advantage over most of the status quo.
Yeah, okay, I understand this now. I think I'm trying to clarify this in my head, and maybe this is helping, that to actually get low latency, I will need to get FQ. If otherwise, there's backward compatibility, but I don't necessarily get low latency. That's what I'm taking away from this.
I would note that deploying AQM of any sort gets you low latency. The question is whether you also get full throughput.
Okay, I think it's clarified my question.
Brian, briefly?
Quickly. Hi, Brian Trammell. Quickly. I should probably sit down then. Let me ask sort of a clarifying framing question in terms of your first point on this slide, so requesting working group adoption. I think if we end up with a working group adoption call and this work adopted by the working group, we will have two proposals for work in the working group that have similar goals toward a similar set of requirements that the working group has adopted, but with different to wildly different deployment stories. Is that an accurate statement? Like in terms of not even wildly different deployment stories, like wildly different deployment targets, like, you know, what you get in partial deployment is different with these two proposals. I would suggest to the working group that a way forward there is to make the deployment part of that story an explicit part of any working group deliverable that we would take on this. I don't know if we're actually going to do the call for adoption. It's just that when I saw that up here.
We are not doing the call for adoption at this meeting.
Okay, then I will sit down, and when we do the call for adoption, I will come up and say the same thing.
And I appreciate that input, and that is a concern of the chairs and our AD, that we do think about how these experiments will run, and if we would sanction two experiments at the same time, we would need to consider that seriously, not lightly.
I would say beyond that, which is, you know, is absolutely a serious concern, is you also want to talk about the incremental deployment story and the transition story for the deployment of these beyond the experiment, because that's where I think that conflict comes in and it gets even hairier.
And also the non-deployment, as in what happens when we want to retract the experiment. These are things that we'd have to consider seriously for doing any experiment using the same set of code points.
Okay, thank you.
Yeah, I do. I also have an answer for the teardown capability, but I'll leave it for another time.
I don't think we can take that at the moment. Mira, are you in line with a comment? Are you in line as an AD, or are you thinking? Thinking. Okay, that's cool.
I used to have a comment, but we can also just break here.
I think we should move on the first line of this by a simple question to start with. Who in the room has read the Draft Morton TSVWG SCE? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 20 people, maybe 25. Okay. Who is planning to use the specs in here or implement them or do experiments with them beyond the team that's developing them, obviously, because the authors are presumably going to progress their own work. But who else is interested or actually targeting experimentation with this at the moment? Are there people? Somebody will be. 1, 2, 3, 4, 5 in the room. Okay, thank you. Is there anything else you want to ask the chairs? I think we have some information there. We won't be running the adoption call this meeting. We can talk more with you offline about what might be required by the working group to have that adoption call.
Certainly.
And I think we should cut to allow the other speakers at least some time.
Okay, thank you.
Thank you very much. We'll take comments on, can we take the QCI draft if anybody in the room wants to talk to that? Do we have anyone in the room wishes to say something? Yeah. Right. We go for the spin bit for. Yes.
This is Subir Das from Perspective Labs. I have a quick question on the process for the QCI draft.
Yes.
I think we had some resolutions in the last meeting.
Yes.
And now I see it's informational. Okay, that's good. But what would be the process from the chair's perspective that will be followed? Is it an AD-sponsored or is it a working group would be item?
It is not a working group item.
Okay.
At the moment, we will have to discuss, and we don't have input to discuss that, and we will also check with other people about their interest in this, including 3GPP, who is impacted. So we will not make that adoption call until we have consulted with people, but we're encouraging people to read and work on the document to make it better.
Okay, thank you.
Can I have the remote control?
You may. We can't give you a lot of time. You've only 3 minutes.
I'll try to be really quick. I'm Fabio Bulgarella from Telecom Italia, and we developed some solutions to improve the delay measurements that is done using the spin bit. I'll be really quick in this part. All of you know, I think, the spin bit working mechanisms. We added an additional bit, the delay bit, that is used to try to solve these 3 main problems that can be found on the spin bit mechanisms. The first one is the packet loss that tends to cause the wrong estimate of round trip time. The second one is the reordering of spin edges that cause the creation of multiple spurious edges. And so the multiple observation of round trip time per spin bit period. And the third problem is the introduction of holes in the traffic flow done by application limited sender that in this case can cause some delay in the edge reflection and so the wrong estimation of the round trip time. With the additional delay bit, we solve this problem. It's a single packet that bounces between client and server, so the measurement is done using the time of 2 consecutive delay samples. Okay, okay, I'll go directly to the second mechanism. That is the one where we want to focus. Okay, we define also a second measurement that is possible to achieve using the spin bit in one implementation, or it's possible to implement using 2 bits, so without relying on the spin bit. We define a new performance metric, the round trip packet loss, and this means that we measure the end-to-end between client and server packet loss in round trip, obviously. How it works. The mechanism is really simple. We mark a train of real packets or production packets. These packets bounce between client and servers and complete 2 rounds. So an observer placed on whatever direction can count and compare the packets in the first round and in the second round and compute a statistically measurement of the loss rate of the connection. The main issue in this case is that usually uplink and downlink have different packet rates, but this can be solved by generating packet at the slowest traffic direction. So using a token system, we can achieve this result.
Can I suggest you park there and just go to the end? Go to your very last slide, and
okay.
Because yeah. And while you're thinking about what you'd like to say as your end, I'll just do a brief update from the chairs on this particular topic. We believe that mechanisms to do this could be talked about in this working group. So this one is a mechanism that's being worked on by people who are coming along to this meeting, and that's great. We also believe that the mechanisms, when they're instantiated in protocols, will be developed within the working groups that they target. So in future, this work will probably be adopted in a different working group, unless it just becomes a generic mechanism. So if you're thinking about why is this here and what its future is, that's the scope. You can have your final say with the last couple of minutes of our meeting.
Oh yes, firstly I want to say that this mechanism can be applied on connection-oriented protocol. So we try to propose it for the quick protocol, but it can be used in any connection-oriented protocol. And this is because we have two implementations. The first one that rely on the spin bit, and the second one that can be used using 2 bits, so without any spin bit implication. And another thing that I want to say is that in this working group, there's another draft that is talking about that talks about loss, and this is the one that is mentioned in the header of these slides. And we did also a slides where we compare the two mechanisms, so it could be interesting to have a discussion about these two mechanisms and try to find the right place where we can discuss this sort of mechanisms. Also because I think they are really useful to understand where the losses are located, because for example, with our mechanisms, we can understand if the loss is before the observer, after the observer, and if we use 2 observers, we can also compute the loss that is between the 2 observers. So this could be a good way to measure the loss inside the domain of the network operators. So I think it's...
Thank you ever so much. And thank you for being so brief in your explanation.
Thank you.
You want to take a couple of short comments? Go.
Eric Kinnear. So I will skip past a lot of the other discussion that we've been having elsewhere anyway. But the 2 things I wanted to say are, first, I thank you for doing this. I think these are interesting measurements to be able to gain. And secondly, I would be much more interested in a generic way to do this rather than trying to push this into each and every protocol that it needs to do. So this kind of feels like the right place to discuss it.
And that's an interesting comment.
Thank you.
Brian?
Brian Trammell, co-chair IPPM, here to agree with and contradict Eric at the same time. I think that there's a question as to, so we have a history of looking at generic mechanisms for these sorts of things in IPPM, so the IOM work is exactly the same sort of thing. I think that in any case, it's a lot of the same people in the same rooms, right? So TSVWG needs to be apprised of this work as it goes forward, because that's where the details of these encapsulations are going to work out when you actually bind it to a transport protocol. But we'd also be happy to see this work in IPPM.
Okay. And adding back, just to illustrate how hard this is, IPPM is the right place to decide what the metrics are, because the expertise lies there. So you probably have multiple pieces to put together. We can do mechanisms, but we would then need IPPM to talk about measurements, and then you would need to influence protocols, none of which should deter you from doing this work. Please talk to other people and find good ways to do this.
Alternately, we could have a discussion in IPPM and TSVWG about where the precise boundary between our charters is on this point, but yeah, who cares?
Okay. Please just work with people to make this happen in multiple places for the moment.
Okay, thanks.
Hi, my name is Stefan from Orange. Actually, we don't care where the work will be done, but do it now.
Yep. Okay,
thanks.
Bob?
Yeah, I just wanted to point to some quite old work now done by the IETF called congestion exposure, which had a loss bit and a congestion bit that the sender put back into the network from its feedback, so that anywhere in the network you could tell how much loss was upstream of that point and downstream of that point from any measurement point in the network.
Thank you.
And that was at the IP layer for generic for all protocols.
Thank you for everybody.
The IESG wouldn't support it.
Oh, go away, Bob. Thank you, everybody, for coming here. A chair's note that there was one person on Jabber said they were willing to work upon SC apart from the people in the room. We will record that. We will be meeting again at the next IETF. We plan to do a lot of work on the mailing list. Please use the mailing list. Please be constructive on the mailing list to address technical comments. Please don't make judgment calls on the mailing list about the value of something, but please make technical comments to try and progress items or to indicate where additional work is required. Thank you ever so much. There'll be no time to discuss, that's the issue. Yeah.
All right, right.
Yeah. I mean,